Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So we proceed by first finding the wavelength using equation 27.8. So here lambda is equal to h over p. Now we are given the kinetic energy to be equal to 445 keV, which is equal to 0.045 MeV or mega electron volt. Now this is much less than the rest mass energy, which is equal to mc square, and for an electron this is equal to 0.511 MeV. So because of this we can use uh, classical formulas for P over here. So P will then be equal to 2 times mass times the kinetic energy root over. Now secondly, we can use equation 24.21 for the two slit interference with a small angle approximation. So here we have d sine theta equal to m lambda, where m is equal to 1 to up to infinity, and we are using small angle approximation, so theta is nearly equal to sine theta, this is nearly equal to tan theta. So we use this in this equation and we get d tan theta is equal to m lambda, and we have x is equal to L times tan theta. So we use these two equations, basically take a ratio of each of the sides, and we get m lambda over L is equal to d over x. Oh, sorry, I took the ratio from the wrong side. So this equation over this, so let's write it so it will be easy for us to take the ratio. So now we can take a ratio. So d over L, because tan theta cancels out, will be equal to m lambda over x. This means that x will be equal to m lambda L over d. So delta x will then be equal to lambda L over d, and we can use the value of lambda here from this equation. So this will then be equal to h times L over d root over of 2 times mass times the kinetic energy. Now here we have to convert the kinetic energy into joules. So in terms of joules, this will be equal to, so this is the value in electron volt, and we have to multiply it by a factor of how many joules are there in 1 electron volt. So this is the value of kinetic energy mm, that we need to use in this equation. So h is the Planck constant, and h is equal to, what should I write? Let's write it over here. So h is equal to 6.63 times 10 to the power minus 34 joules per second. So Now we have all the values. Well, we don't have mass of the electron, but that's pretty common. Okay, so now we can solve for delta x and we get this value to be 1.3 times 10 to the power minus 6 meter, or we can say write this in terms of micrometers. Now note that while doing the calculation, make sure you convert all your units, all the units of length into meters. And obviously the energy should be in joules.